Right, so this will be section 7.2 part 4. It does say part 3 on here. That's because we used to do this section altogether, but then we split it off. So kind of a continuation of the part 3 notes, what it looks like on my notes, but for your assignment it'll be section 7.2 part 4. And what we're doing now is we are using your trig identity sheet. We're using the very bottom left hand corner, the sum to product formulas. Really make sure that you have the plus signs. The copy that I have, the plus signs don't really show up very good. So make sure you're checking that against what is on what I put on the calendar, the My Open Math calendar. Make sure you can read where your plus and minus signs are, because I know mine wasn't very good. Okay, so example 3, write the sum as a product. So what we're doing is we're going backwards from what we were doing in part 3. So now we are going to be looking at the left hand side where it says sum to product formulas, and we're going to be following those. So second one down is the sine minus a sine formula, and I'm just going to write that formula down. So formula is sine of A minus sine of B is equal to 2 sine of A minus B over 2 times cosine of A, hold on, my head's not doing very good. Okay, cosine of A plus B over 2. Why are you doing that to me? My writing pad might be running out of batteries. Okay. Over 2. Okay. Alright. One of these days I'll get used to writing on this slate. Alright, so we need to fill all of this out. This is going to be our A value. This is going to be our B value here. So now we have 2 sine of A minus B. I already calculated all these, so A minus B, 8.2, 16.4. Yeah, 16.4. B over 2, and then cosine of 31, 31b over 2. Very good, and then we're just going to simplify that. So 2 sine of 8.2b and cosine of 15.5b. Double check our answer. Yep. And that's all we have to do for that one. Alright, we'll go on to example 4. I'm going to move my board around here a little bit. Okay, and we are back again. So now we are going to be using the identity with the cosine A minus cosine B, which is at the very bottom of your sheet. So we'll write down that cosine of A minus cosine of B is equal to negative 2 sine of A plus B over 2. A plus B over 2. And then sine, again, of A minus B over 2. Okay, now let's go ahead and fill in what we have. 22.4b will be A, and 9.6b will be B. So let's rewrite that. So we've got negative 2 sine of A plus B, which is going to be 33, right? — 32, yeah. 32b over 2. And then sine of A minus B, which is 12.8 b over 2. And now simplifying that, we have negative 2 sine of 16b, 16b, and then sine of 6.4b. That's 6. All right, and that's our answer for example number 4. So for those first couple problems on your homework assignment, they should be pretty easy. Just go ahead and follow that identity, and you will be given those identities on your quiz. All right, next example, we have find all solutions to cosine 3t minus cosine t equals sine of 2t on the interval from 0 to 2 pi. So let me rewrite that interval here so it's all in one. So our interval that we're looking at is between 0 and 2 pi. All right, so this is another equation we're going to have to solve. All of this right here is different. So notice we've got cosines, we've got sines, all the numbers inside the parentheses are different. So there's just so much going on, and we want to be able to rewrite this in a way that can help us solve this equation. So let's look at these formulas, and look at the sum to product formulas and see if we can do something that would help. Now if we use that cosine A minus cosine B formula, that's going to change it into a negative 2 sine of A plus B over 2 times sine of A minus B over 2. Now I think this would really be helpful because at least we'll have everything in terms of sine. So let's go ahead and change that and see what we get. So then we will end up with negative 2 sine of, let's go up here and see what our A and B are. A is going to be 3t, B is going to be t, so we have negative 2 sine of A plus B, which is 4t over 2, and then sine of A minus B, which is going to be 3t minus t, which would be 2t over t, 2. Yeah. 2t over 2. There we go. And then simplifying that, let's get our equal signs up here. We'll have negative 2 sine of 2t sine of t, and all of that now is equal to our sine of 2t. Okay, so I'm going to go ahead and set this equation equal to 0. Don't be tempted to divide both sides by that sine of 2t, because that's going to lose quite a few of our answers, of our solutions. So don't do any division there. What we're going to do instead is we are going to subtract sine of 2t from both sides and set that equal to 0. So we have worked with some of these problems at the beginning of section 7.2. So what do they both have in common? They both have a sine of 2t in common. So let's rewrite that. We have negative 2. No, we want to factor that out. Let's start over. Let's go ahead and factor out that sine of 2t. Once we factor that out, what do we have left? We have a negative 2 sine t minus 1. Right? And that is equal to 0. Okay, so now we have two parts, either sine of 2t equals 0, or negative 2 sine of t minus 1 equals 0. Okay, so that's going to give us some work to do. We've got to find where all of those answers are. All right, so this is where the bad news comes in. We have done a lot of problems like this, where we have the sine of 2t is equal to 0. Up until now, they've always given us like an amount, like find the smallest one, or find the first 4 answers, or the first 3 solutions, or maybe 2 negative solutions. So we've had lots of different information come in for those. But now, all they are giving us is an interval. They're giving us this interval from 0 to 2 pi. For our second solution, let's look at the ones that we're talking about here. For our second solution, right here, notice that our interval is just t. So the period of this sine function, and remember, these are actual equations, these are actual graphs that you guys could graph and look at. Now, t is going to be just one, well, let's see. Okay, think of the period of this one. The period of this function right here is going to be 2 pi over 1. So the full period is 2 pi, okay? So p equals 2 pi of this equation if we graphed it. Well, our answer wants all solutions between 0 and 2 pi. So that's only going to be one period of that sine function. Well, we know that one period is one circle around the unit circle, one time around the unit circle. So that's going to give us 2 solutions. So we are going to have 2 solutions for this answer. Okay? Problem comes when we get over here. Over here we have the sine of 2t. Well, the sine of 2t is what? What is the period going to be? Well, b equals 2. So the period is going to be 2 pi over 2. So if we were to graph the sine of 2t, which I know all of you could do, if you were going to graph the sine of 2t, the period would be pi. So if we want all solutions between 0 and 2 pi, when our period is only pi, that's going to give us 4 solutions. Okay? So we're going to end up with a total of 6 solutions on this. Now I'm going to show you a little bit easier way of keeping track of what all your solutions are. So what we're going to do up here is we have the only one that's a problem. Let me switch my pen back here. The only one that is a problem is the sine of 2t. Okay, it's equal to 0. So if I want my interval or my domain to be between 0 and 2 pi, for t, let's look at what happens when we change that to 2t. If I want to change this to 2t, I have to multiply all sides by 2. So I'm going to multiply everything by 2. And look what I get. Now, what I'm really getting for all of my solutions for 2t is between 0 and 4 pi. Now what do I do when I solve this? I'm going to take this 2t out, and I'm going to set it equal to 0. I'm running out of room. Let's do this down here. So we have u equals 2t. So what can I do now? I can come back up here and I can say u is between 0 and 4 pi. This gives me my solutions in terms of u. Just like before when we said if you have to find 4 solutions, find all those solutions in u first and then find t. It's kind of the same thing. So it's very helpful if you can go ahead and change your domain in terms of u. Then we know how many solutions to find when we're in u, and we can translate that back over to t after we're done. So I'm going to take my sine t, sine of u equals 0. And let's look at a unit circle. Where is sine equal to 0? Well, that's going to be at 0 pi. But remember, I've got to go all the way to 4 pi. So 0 pi, 3 pi, and 4 pi. Those are going to be all of the places because we got to go around 2 times to get to 4 pi. Now, that's all u. Plug that back in for 2t. I'm going to run out of time. This is all I'm going to do. But go ahead and divide everything by 2 now. Those are 4 of your solutions. And I know you guys can find the last 2 solutions here on your own. So we would end up with t equals 0, pi over 2, 3 pi over 2, and 4 pi over 2.